Which definite integral is represented by this summation? Well, this is summation notation, and basically it takes the idea of Riemann sums and it takes the idea of adding up a bunch of areas and turns it into an integral which is supposed to look like that. Since we start at 1 and end at 6, we start at 1 and end at 6. And since I have 2i squared plus 1, it's going to be magically transformed into 2x squared plus 1, and we'll put that in parentheses, and you always attach a dx to the end. So in this case, this guy is going to look like a. What is the definite integral notation of the following? You have sigma notation with a limit as n approaches infinity. You start at 1, you end at n. All of this terrible, terrible, terrible stuff. All right, so this is what we've got going on. We've got ourselves a 3i over 2. All of it is going to be squared. You got a 6i over n. Okay, when you're dealing with sigma notation, first off, let's apply that squared. So we have sigma n I equals 1, limit as n approaches infinity. Let's apply that squared so you become 9i squared over 4. You become still 6i over n. Now when you're dealing with sigma notations, when you sigma this, okay, any I becomes x. When you sigma I over n, it becomes 1. Okay, so what's going to happen here is if we just make believe that sigma is attached to both, let's get rid of all this limit stuff and just read it. Just let's simplify it and rewrite it like this, just to make life easy. Okay, sigma, sigma. Okay, rip out a 9 over 4. 9 over 4 is sigma I squared. Okay, rip out a 6, sigma I over n. Okay, once you have that, we can now kind of apply these rules here. The sigma of I squared is going to be x squared, so you become x squared with a 9 over 4 attached. You become 1, so plus 6 times 1 is 6. When I look up here, the only one that applies to that is going to be C. So C is going to be my answer. Okay, now the reason why we have 0 and 3 is because of the way that this is graphed. If you were to graph this and do a little bit of solving, you would have just an integral between 0 and 3. But yeah, it's kind of sigma notation when it deals with these limit things are kind of gross. But that's what we get here. Fun stuff. Which of the following expressions is equal to the limit as n approaches infinity of this monstrosity? All right, so we're kind of comparing this stuff to sigma notation. I'm comparing this to what essentially is this. Limit as n approaches infinity of the sigma from whatever, k equals 1 to infinity, right? And it's always going to be b minus a over n. And then we have times f of a plus b minus a over n k. Okay, now this is normally supposed to be f of x, so this whole thing is x. When I look at this and I see 1 over n and I'm comparing 1 over n to b minus a over n, that tells me that b minus a is 1. Okay, so we're dealing with a change. Remember, integrals look like this. The difference between b minus a is going to be 1. So that knocks u out of the question. Okay, so at least we can pull that off. Now what I also know is b minus a is 1. So my x is going to look like, some a, which by the way, if all of these look like that, that tells me right there that a is 1, a is 1, a is 1, a is 1, which means u are going to be 1, and if b is going to be 1 more than that, 2, which knocks u out of the question. Now what I have to do is figure out, okay, well, hold on, x is going to be a, which is 1, plus 1 over n times some k. Well, here we are, and that k is going to be 1, so hold on. So if k is 1 and it starts out there, and k is 2 and it starts out there, right, I basically have everything I need. So if you're going to be 1 and you're going to be 1, that is exactly x. So my f of x is going to be e to the x. I'm not going to add 1 to it. I'm perfect. I'm there already. So this ends up being b because of all the little bit of math stuff that I could do to find out that it's b. Confusing? Yeah. Easy? No. But that's how I would do it. I approached it a little differently and I kind of like it.